Okay, here we go on 24. This is a problem that right now we're just doing a lot of estimating, and as we learn more um, calculus, then this becomes a really simple problem to do. So we'll kind of try to point you in that direction a little bit. So 24, ball is tossed into the air from a bridge. The height, y feet above the ground, t seconds after it's thrown, is given by that formula. How high above the ground is the bridge? Well, at t equals 0, he's standing on the bridge. So y would be negative 16 times 0 squared plus 50 times 0 plus 36. This is the height above the ground at t equals 0. So y would be 36 feet. Okay, so there's A. B, the average velocity for the first second. So average velocity from t equals 0 to t equal 1. So we know by now that's going to be f of 1. That's its height at 1 second minus f of 0. So that's the distance it traveled over 1 minus 0. So f of 1 would be, if I plug 1 into there, negative 16 plus 50 is 34 plus 36 is 70 minus 36 divided by 1, which is going to be 34 feet per second, right? Because the top is feet, the bottom is second. Okay, so that's its average velocity from 0 to 1. C, approximate the velocity at 1 second. Well, the average from 0 to 1 is 34, and there's actually lots of ways to approximate the velocity. We can use the graph if we want to just kind of eyeball it. When we learn, well, if we take the limit and use our limit definition, we can find the exact velocity, but it didn't ask us to do that. It said just approximate it. So let's look at the average velocity from t equal 1 to t equal 2. So that's going to be f of 2 minus f of 1 over 2 minus 1. So f of 2, that's going to be, let's see, 72. If I did this right, negative 16 times 4 plus 100 plus 36 is going to be 72 minus f of 1, 70 over 1, which is 2 over 1, which is 2 feet per second. Okay, now we can see this doesn't really help me much with approximating it. It's going to be probably somewhere between those two values. So let's take a look at this. The average velocity from t equal 1 to t equal 1.01. And you're probably asking me, why didn't you do that in the first place? Because I wanted to look at, I'm just thinking in terms of whole seconds first and go, okay, that might be close. If this was 34 seconds, I'd be pretty confident saying that instantaneous is close to 34. So let's try this. So we got f of 1.01 minus f of 1 over 1.01 minus 1. And so now I've got to come over here on my calculator and put it in. And this might take a couple seconds, so I'm going to pause it. Okay, so we do f of 1.01 and we get 70.17 minus f of 1 is 70 divided by 0.01. We get 0.17 divided by 0.01. And what does that give us? Feet per second. That's a pretty good approximation from 0 to 0.1. Okay, sorry about that. I just realized this is still part of C here. So let's jump up to or look at D, which is graph it. And so if I graph it, I went ahead and put it on here already. There's my function, and if you set the window to -5 to 5 and 0 to 100 for the y's, and then graph it, it's going to look something like that. So I should just leave that there. There it is, right? So it says, determine the maximum height the ball reaches. Well, how do I figure out what the maximum height is going to be right there? Okay. All right, sorry. The maximum height is going to be right here. And the nice thing is, our calculator, if we do second calc, it actually finds the maximum value. And it says left bound, so I'm going to go to the left of, oops, to the left of what I think is a maximum. Oh, I'm not sure why it's doing that, sorry. Enter. And then I'm going to move it over to the right. And it'll find the maximum between them. It says guess. So the max height happens when x is 1.56 and it's 75.06. So 1.56 and the maximum is 75.06. And the reason I'm finding the maximum, because that's, well, the maximum height is the y value, that and the velocity at that point is 0, because the tangent line is horizontal and the slope of it is the velocity. Remember, this is the position or height of the ball. So the max height is 75.06 feet at t equals 1.56 seconds, and the velocity at that point is zero. And we know that twofold. We know that when you throw the ball up from 36 feet here, at the very highest it's going to stop for an instant and then it's going to fall down. But we also know, because the rate of change of the height is 0 at that point. It's not going up or down at all for that instant. Okay, and so we actually answered E in the same one by finding the time it takes to reach it, which is that. All right, there we go on that guy.